Okay, so let's continue our episode on the BECE, questions as our students prepare for the upcoming BECE. We wish them the best in their first standardized exam that they're going to write. Now let's begin. A rectangular tank has length 60 centimeters, width 45 centimeters, and height 50 centimeters. And we have to find I, the total surface area of the tank when closed. So this is what you're supposed to know. A rectangular tank is a cuboid. So we are just finding the total surface area of a cuboid. So this is a formula work. If you know the formula, you can work it. So before we do it, let's write down the information given the question. So the length has been given. Remember to write the question number, that is 1AI. So let me get that one here, 1AI. And now let's see the information given. We have the length. Let me use L, capital L for the length. So that's going to be 60 centimeters. The width, capital W, also was given to be 45 centimeters. And the height, I'm using capital H, that is 50 centimeters. So these are the information given in the question. Now, how do you find the total surface area of a closed, cuboid, or in this case, a rectangular tank? So this is the formula that we're going to use. I'm using TA for the total surface area. And the formula is 2 into bracket L times W plus L times H plus W times H. So that is the formula that we are using. That's a simple formula. So it's like we are just pairing the letters here. So you see I paired L and W, that is LW. I also paired L and H, and that is here, and W and H. So that's a simple way. And remember to multiply by 2. Yeah, because whenever you take a cuboid, opposite, faces are identical. So when you take one face, it is identical to the opposite, face. So, that is why we multiply by 2. So that you know that we are working or we are dealing with, opposite sides or opposite faces. So that is it. So now we just have to, do our substitution to find the total surface area. So we have total surface area to be equal to multiplying the length, which is 60. So that's going to be 60 times W, and W is 45, plus L, which is 60, times H, which is 50, plus W, which is 45, times H, which is 50. So that is what we're going to do. So after that, we have to simplify the ones in a bracket. So we have 60 times 45, and that's going to give us 2,700. So we have 2,700 plus 60 times 50. That's very simple. We just have to multiply the 6 by 5 to get 30. So that's going to be, 3,000. So we have 3,000 here plus 45 times 50. So that also gives us 2,250. So these are the values that we're going to get. So what do? We have to still simplify the ones in a bracket. So we have 2,250 plus 3,000. That will give us 5,250. Now plus 2,700. And that will give us 7,950. So to get the total surface area, we have to multiply 2 by this. So by 2, now will give us 15,900 centimeters square. Remember to attach the units. So that is centimeters square because this is area. So that is how we can find the first one. That's the total surface area of this closed tank. Now let's come to the volume of the tank. So let's get that one here. That's going to be 1A. Always remember to write the question number. That's very, very important. That is 1AII, the volume of the tank. So this is another formula way. You see, these questions are formula based. If you know the formula, you can just, work it out. So now, the volume of a rectangular tank, which is a cuboid, now since I'm using these, parameters, length, width, height, it's going to be the length and the width times the height. So that's going to be, the volume of this rectangular tank. So what do? We just have to do substitutions, and that's going to be 60 times 45 times 50. So the volume is going to be 135,000 centimeters cube. Volume as a unit of cube. So don't forget to write that. So that is how we can find the volume of the tank. 135,000 centimeters cube. Let's get the next question solved. Now this is the next question. We have to find the height of the water in a tank if the tank contains 1,000 centimeters cube of water. We know that the total amount of water that this container can take is 135,000 centimeters cube. But we have been able to fill this container with 81,000 centimeters cube. That means it is not full, or it is not to the brim. So that's the amount of water in the container. Now we want to know the depth of water in this container, or the height of the water in this container. So what are we going to do? Now, it is the same container that we are talking about. So it means the length, which was given in the question to be 60 centimeters, is still going to be, the same length. And the width is going to be the same width. That was 45 centimeters in a question. But the height is going to change. And that is what we are going to look for. Why? Because the volume of water in a container is not the same as the total amount of water that the container can take. So this will come with its own height, and that is what we are going to look for. So what are we going to do? The volume of the water has been given. That is V equal to 1,000 centimeters cube. So I'm still going to use the volume formula, and we know that the volume is equal to the length times the width times the height. So in this case, where I see the volume, I'll just substitute 1,000 centimeters cube. So that's going to be here 1,000 equal to the length, which is 60, times the width, which is 45, and for the height, we don't know. So I'll just have to put h there. That is what we are looking for. So what do? We have to divide the whole of here by 60 by 45, the whole of this side to 60 by 45. So this one, just do away with this one. So now we have h. After doing the cancellation, you find out that the volume, the height is going to be 30 centimeters. It's a whole lot of stuff, but you should be able to, cancel out to get a final answer. And the height is 30 centimeters. So let's get the question 1b solved here. So that's going to be 1b. And what are we solving? That is the question. So to evaluate the root of 50 plus the root of 32 minus 6 on the root of 2. That's a simple question. This is set, and another simple question that we're going to evaluate. Now what are we going to do? So let me write the expression here. We have the root of 50 plus the root of 32 minus 6 on the root of 2. So that's the expression. Now we are going to simplify these roots, the root of 50 and the root of 32, and we will have to rationalize this one because the denominator is a set. It is not acceptable to leave a denominator of a fraction as a set. So we have to rationalize this denominator. So now let me begin with the root of 50. We just have to look for two numbers that when you multiply you get 50. But when you get a perfect square in a multiplication, it will help you a lot. So I'm going to use the root of 25 times the root of 2, because 25 times 2 will give you 50. So I can break the root of 50 down to the root of 25 times the root of 2. Now we come to the root of 32. With that one too, I can think of the root of 16 times the root of 2. Now minus 6 on the root of 2. We have to rationalize the denominator. And how do we do that? We just have to multiply the root of 2 by both the numerator and the denominator. So it's going to be like this. So this one by the root of 2, and here too by the root of 2. Now let's say something. Before we continue, we should remember this. Whenever you multiply the root of a number by itself, for example, the root of 2 by the root of 2, you're going to get 2. Yeah, it happens to any other number. So that's going to be, for example, the root of 3 times the root of 3 is going to be 3. The root of 4 times the root of 4 is going to be 4. And this is the reason. The root of 4 times the root of 4 is the same as the root of 4 squared. And this square can cancel the square root, and we are left with 4. So the same thing applies to the other numbers, and that is why we are getting the same number. So anytime you multiply the root of a number by itself, you get the number without the radical sign or without the root sign. You have to take note of that because it's going to be very, very important in most of the questions that we solve. So let me clear this stuff from here. So let's continue. We have the root of 25. 25 is a perfect square. And I mean 25, the root of 25, that's going to be 5 because 5 times 5 is 25. Now times the root of 2. 2 is a prime number, so we cannot simplify. So you're going to get 5 times the root of 2 plus this one too, the root of 16. 16 is another perfect square. And the root of 16 is going to be 4 times the root of 2 minus. Now let's come to this one. 6 times the root of 2, that's going to be 6 root 2 all over, 2. I just explained that the root of 2 times the root of 2 is going to be 2. So this is what we have. We can still simplify our expression. So now 5 times the root of 2 is going to be 5 root 2 plus 4 root 2 minus 6 root 2 on 2. Now these two guys here, they can be simplified because the radicals are the same. I mean, this is 2, this one is 2. You know that when you are adding sets, the radicals should be the same before you can add. For example, the root of 3 plus the root of 5 cannot be added to get the root of 8. This is not correct. So we have to take note of that. Now we can still simplify this expression. 5 root 2 plus 4 root 2 minus this one. You should know that in adding sets, the radicals should be the same. I mean, the guys in the root should be the same. If not, you can't add. So for example, the root of 3 plus the root of 5 cannot be equal to the root of 8. We can't add this 3 to 5. We don't do it like that. We have to make sure the radicals are the same. So we just add the coefficients. So let's see how we're going to do this one. Let me clear this stuff from here. Let's see how we're going to, simplify this one. So now we're going to get 5 plus 4. We just have to add the coefficients. These are the coefficients. 5 and 4. We add them to get 9. Then we take one of these, which is the root of 2. So we don't even add the ones in the bracket. In the radical sign. We just take one of them. Now, minus, let's see something. Maybe you didn't think of this one. 2 can also cancel this one. 2 here, 1. And 2 goes into 6, 3 times. So you're going to get 3. So this is what we have. Now, what do we do next? Like I told you just now, we can also subtract these, sets because the radicals are the same. 2, 2. The radicals are the same, so we can subtract them. We just have to subtract the coefficient. So that's going to be 9 minus 3. Then we take one of these guys. And 9 minus 3 is going to be, 6 root 2. So that's the final answer. That is how we can evaluate this expression. Let's take the last one. So the last one is 1c. We have 1c here. Given that 3 exponent 1 plus b is equal to 9 root 3. You have to find the value of b. So what do we do in this case? We have to make sure that, so this is an exponential equation because one of the exponents has an algebraic expression that is 1 plus b. So this is an exponential equation. And for exponential equations, always think of, the bases becoming the same. And you know that when the bases are the same, then automatically the exponents will be the same. So we have an expression like, let's say, 3 on 2 equal to 3 on x. You see, the bases are the same. So we can conclude that then the exponents are also the same. So that means x will be equal to 2. So that is the idea that I'm going to use here. So you have to simplify this expression in such a way that the bases will be the same. So let's do that right now. You see, 3 cannot be simplified. It cannot be simplified again. So I'm just going to write the same thing. 3 exponent 1 plus b. But on the right hand side, something can be done. 9 can be written as 3 exponent 2. Now times the root of 3 is the same as 3 exponent 1 over 2. Take note of that. That the root of a is the same as a exponent 1 on 2. So this is a rule that you are supposed to know. We can now simplify our expression as this. So we have 3 exponent 1 plus b equal to. Now what happens to these guys? The bases are the same and they are multiplying. So what do? We have to add the exponent. So that's going to be 3 exponent 2 plus 1 on 2. So that is how we are going to, simplify this one. So now the bases are the same. So now that the bases are the same, then we can equate their exponents. We just assume that the exponents are also the same. So this implies that 1 plus b is equal to 2 plus 1 on 2 because the bases are the same. So this becomes a normal equation, whereby we can simplify to do away with the fraction. The LCM is going to be 2. So we just have to multiply the LCM by the terms. So I'm going to get 1 times 2 plus 2 times b equal to 2 times 2 plus 2 times 1 on 2. So I've just multiplied the LCM, which is 2, by all the terms. The terms are 1, 2, 3, 4. So that is what I've done here. So 1 times 2 is going to be 2. So 2 times b, that's 2b already. So 2 times 2 is going to be 4. Now, let's see something. 2 here, 1. 2 goes into 2, 1. So we have 1 times 1 to be 1. So we have plus 1 here. So how do we find the value of b? So you just have to take 2 to this side. So we have 2b equal to 4 plus 1 minus 2. So 2b is equal to 4 plus 1 is 5. 5 minus 2 is going to be 3, which we can simplify to get our final answer by dividing here by 2, here 2 by 2. So 2 will cancel this 2. 2 cannot cancel this 3. So we're going to get b equal to 3 on 2. So that is how we can find the value of b.